George from Endurance sent me the sample MO2 box, and this is it here. This is just a little introduction, and I've been running some tests. I wanted to see just how well it performed, and it's really good. Got some really good results, and I got some interesting results as well, and I'll cover those in a few separate videos to follow this of how I did these tests. But one of the things I did after taking countless measurements on these bits of paper here was I plotted a graph and compared various PWM frequencies against laser power output, or the current that the laser was consuming, and I got various plots. Now, don't worry about trying to see too much about these. The final edited video, which you will see, will show these more closely, and I will post the spreadsheets on the Endurance Facebook page. So, as well as doing that, of plotting the PWM frequency, PWM percentage, and the relative laser current, and that directly relates to power. I did some burn tests, and I've got some comparisons here, and I'll also be taking some still photos of these and including those into the video as well. So that's basically what I did. I ran some tests. The normal cutting tests were pretty standard, using air assist, cutting through acrylics and plywood. It performed those at 100% power extremely well, so there wasn't a lot to do as far as that sort of testing is concerned. I wanted to concentrate more on the characteristics of the MO2 board with relation to frequency and PWM percentage setting. This is the setup here. I made a special little box which I will cover, that allows me to project the laser directly into this box to do my tests, so I can do all the tests without having to wear protective goggles at all. I've got power supply, 12 volt, 20 amp power supply, PWM generator, a small one, which I will cover in another short little video, and the MO2 box. When I received it, it was set for probably around about 2 watts or something like that, fairly low. So I adjusted internally the current and the voltage to give me pretty much maximum of what I would designate to be around about 10 watts of output, or between 8 to 10 watts. Showing the PWM generator that I use. I purchased this off eBay. They're very cheap. They're only like about $15. You can run them from 5 volts, 12 volts. Currently I'm running this one off 12 volts. There are a couple of different versions available. This one has a knob to control the frequency and the PWM percentage. The way it works is that if I press this once, I'm able to control the frequency, and it'll go down to, I think, 1 hertz up to, I've never had it beyond about 7 kilohertz, so it's got a fairly wide range of frequencies. And if you just leave it for a second, then when you start to rotate the knob again, you've got PWM percentage. 1, 2, 3 in steps. There's another version that I have on my machine which actually has push buttons. So on one side it's got push buttons up and down for frequency, and on this side it's got push buttons up and down for PWM percentage. I prefer that one better, but I had this extra one, so I used this one for my tests. if I show you, scan over here to the oscilloscope, if I'm varying the PWM percentage, you can see gradually it starts to get wider. So that's currently running at about 20%. If I get up to close to 50%, and then if I go all the way up to 100%, you'll see that it maxes out and I just get a straight line at the top. As I go down, it will drop off. Now, if I set that, for instance, to say about 50%, and then I'm changing the frequency, you can see that the ratio of the gaps remains the same, but I'm increasing the actual frequency, so there are more cycles. So that's currently at around about, I went from 2 kilohertz to 3 kilohertz. So that's the frequency variation, and it works extremely well. And if anyone wants to find these on eBay, I will try and post a link, but it's very easy to find them. Lots of different suppliers have these, different types are available, and it's just a nice little thing to have, especially if you want to test your laser out and you don't want to have it connected to your machine. I've got a 12 volt 20 amp power supply. I have a PWM generator which allows me to set frequency and percentage PWM output 0 to 100%. I've got the MO2 endurance sample box. I'm powering that into one of my laser diodes, and what I've also got, so that the light is not splattering all over the place and I can do this without having to wear goggles, I've got a box that I've got set up here. Inside that box there is an aluminium block with a piece of anodized black aluminium on the face that the laser diode shoots into, so that stops any reflections, and a small hole, so that literally fits up and the laser diode shoots into that, and that contains most of the laser diode light. I'm taking measurements from 1 kilohertz in steps to 2 kilohertz, 3 kilohertz, 4, 5 and 6 kilohertz. So I'm going to plot a graph of all of those measurements, and the bottom line here is my PWM percentage. If I have it set at 0, I've put that here and you can see there's no laser light. If I put it up to 1, there's a little bit of light, and you can see it gradually increasing as I'm winding this up. So winding that back again, I'm looking at the current on the meter here. 4.8 volts is fairly consistent. If I wind that up to say 1%, you can see I've got there around about 4.3 or 0.43 amps, 0.39. So I can then take my current measurements. So winding that back to 0 again. So that's how I take all the measurements, and for the moment I just write them all down on this chart here, and then I will plot that using Excel into a spreadsheet and see what the results look like. So this is the graph and the burn test, and I'll cover this in a little bit more detail. But what I've got here is on the bottom line here, I've got the various frequencies. I tested it at 1 kilohertz, 2 kilohertz, 3, 4, 5 and 6 kilohertz, and this bottom line here is the PWM percentage setting, and up here we've got the current that the laser diode is consuming, and you can see very distinct differences in patterns. This red one here is 1 kilohertz, and the laser diode doesn't really start to kick in until you get to around 15% or a bit over 10%, and you can see a very rapid climb. Then it's fairly linear till it gets to the top, then it rolls off quite nicely. But at 1 kilohertz, not really usable. Then we go to 2 kilohertz, which is the blue line here, and that's pretty good. That has a nice ramp up, and then a linear curve right up, and it flattens out really nicely. This point here is around about 80%. So between 80 to 100%, not a lot of change. As you go up in frequency, and there are various steps here, you can see here that at this one here, which is 6 kilohertz, you get a very rapid rise at the start. So you literally are at around 50% by the time you get to about 5% of PWM. Then you get a rise up, and then it literally flattens out from about 40%. So at 40% to 100% PWM rate, there's not a lot of change. You're basically running at full power. So my burn tests that I did, and my conclusion to this is that around 2.5 kilohertz is around this point here is fairly good. And I did run a test there, which is not plotted, and it basically followed the midline of this all the way up. Now, this chart at the bottom here, I will point out, is not linear. I wanted to concentrate on the bottom end, so I did it from 0 up to 10% PWM, and then I jumped in 5% jumps up to 50%, and then from 50 I then went to 100%. So if I had have tried to do this whole thing linear at 1% increments, I would have been here for the next 10 years plotting all of this. But all the graphs are done based on these same increments, so it gives you a pretty good idea of what the actual plot looks like. What I did then, I did some actual burn tests using a piece of light pine, and I ran the plot pretty much the same at the bottom end as this is going up, just so I could see what the shading was like. And you can see from here that at 1% there's literally no mark at all. 2% just, you might not see it in the camera, but just a slight bit of shading, and then all the way up here to 10-15%, you can see I'm getting a nice gradual rise, which is representative of what it would be there as far as the laser power consumption. And then once I hit 15, I took some bigger jumps, but you can see there is still a nice gradual increase in shading at 5%, 10% increments till I get to about 80%, and then from 80% on, it pretty much stays the same shading. So the main part of a good shaded section is between 1% and up to around 80%, which is what this chart actually shows, because at around 80%, that's about there, everything starts to flatten out. What I did just to confirm this top part here is I did some other burn tests from 80, 82, 84, 86, 88, and then 100, and you can see there's very little change in the discoloration or burning of the wood. So that gives you an idea that this chart actually is a representation of the laser output power and the shading of burn shading that you would achieve. Okay, hope that bit is interesting to you. Thank you. I've now got the MO2 board mounted onto my CNC router and all plugged in and operational. I haven't actually fired it up yet, but this is just showing you how it's currently set up and mounted. This is the very first test. I'm just going to engrave a small cross onto a piece of anodized aluminium. Here we go. And that's it, and we're just going to see what that looks like. Get that in focus. Yep, pretty good. This is a second test, engraving a ruler onto the anodized aluminium. You'll see the laser power is coming on and off, 4.6, 4.5 volts and about 3.37 amps. Temperature 18.4 degrees. This was the engraving test I just did. It's a set of parallel lines spaced 0.075 millimeters apart, and you're not going to be able to see it on the video, but there is a slight black gap in between each line. Box, as I have got it set up for my test purposes. Functionally, this is the way it works. I've got it connected to my 12 volt power supply here. If I switch the power on and then I switch the MO2 board's power on, displayed here I've got the input power from my power supply, which is currently measuring 12.4 volts. I've got here the laser drive power. Voltage is currently at 4.8 volts, zero current because I'm not driving it at all yet. I have the temperature display from the laser cooling block. If I switch this button here to the number 1 position, it's going to put the laser into full power. So I have my current and voltage set for full power here at 4.44 amps, and you can see the laser is on at full power. Temperature is now up to a little bit like 20 degrees C. If I return this back to the 0 position and I start to wind my PWM TTL signal up to 1, you can see that the current is gradually increasing, 1, 2, 3, 4, and if I wind it back you can also see that that's 0, and as I go up you can just see that the laser output light is increasing, and as I continually wind this up it will get eventually to 100%. But the voltage is remaining stable, so fixed voltage, and just the current is increasing when I wind the TTL signal up and down. What I did with wiring the MO2 box up, when I received it, all these wires are bare. I put a connector on here which is the black and white wire, and that goes to directly to my laser diode. Up here I've also got the 12 volts for my cooling fan on my laser diode cooling heatsink, and I also cut the temperature sensor wire so that I could easily separate the box from the laser head, and I used an RCA male and female connector for that. So all of these go into the laser itself. The only other signal I needed to be concerned about was my input for the PWM signal, which then just goes to my PWM generator, and when this is connected to my machine, this will obviously go to my control box, which also has the other version of this connected to it. and that's all that's really needed to power the whole thing up. If I take the cover off the box, it's very, very well made inside, very neat. I've got the DC to DC converter here, and right down just there, if I get something a little bit pointier here, we've got the current and voltage settings for the laser diode drive. And just so that I remember what these are, I just wrote an A and a V on the box there, so I know which one to control. The main one you'll be adjusting is the voltage one if you need to. But if you're buying a complete kit from Endurance with the laser diode, say as an 8 watt or 10 watt plus, then you won't be needing to adjust these unless you're feeling adventurous, because they'll already be preset by Endurance in their factory. This is the MO2 board here itself. A bit hard to get my camera in there. This is the MO2 board here itself, and I don't know, but if previous people have seen the MO1 board, will notice a huge difference between the quality in manufacture of the MO2 board compared to the MO1 board. This is a professionally made printed circuit board. Here we have 2 potentiometers on the board that are used. One is used to set the threshold limit for the laser drive voltage so that you can't overdrive it, and the other one is set for the calibration mode. Generally, when you receive the box and the board, these will all be preset and you won't need to adjust them or be concerned about it at all. But everything else is wired and connected. It's very neat. So all you really have to do when you receive it, you don't have to worry about too much about what's inside this box. You'll only have to connect these outside wires to whatever system you've got. So a very, very professional job there in making this box. The only thing I don't like about it is, for me, green. I don't like green, so I'm just being pedantic with regard to the colour of the actual MO2 enclosure. Black would have been a lot nicer, but functionally, regardless of the colour, it still works just as well. Just going over the wiring again for the box. When the box comes, all of these wires will be bare ends, simply because different machines require different things. The way I've got my machine set up is I've got specific connectors on my laser head here, and these just match up with these connectors. So I've got a polarized 2-pin connector for my laser diode. I've got an RCA connector so that I can unplug and plug in again my temperature sensor, which is going to the laser diode heatsink. And then I've got my PWM signal input on this connector. I've used different connectors just so I can't get them confused and plug the wrong thing in. What I also made up was with this particular setup here, which the laser box itself comes with a 12-volt input, but quite often you've got to power somehow the cooling fans on your laser diode module. So I made up this so that my 12-volt power comes in here from the laser control box under my CNC machine, and I just split this out to another female type connector, which then goes to the fans that cool my laser diode block, or it may go to also have a separate one if you've got a laser diode with a Peltier or Tech cooling, and this plugs in here to the laser box. It would be actually nice if there was also a straight through connection from the laser box out the other side here to a connector, or a connector somewhere where you could easily plug and unplug the cooling fan for your laser diode, but that's another story. So just in conclusion, I would like to express my sincere thank you to George and Endurance for allowing me to be one of the testers for the MO2 board and box. It's very impressed with the quality of its build and the professionalism that it's been put together with. I got very good results from it. I found it very easy to set up and to get working. Vast improvement over the MO1 board. I did a lot of extensive testing, mostly concentrating on the linear characteristics of the board itself, and I had it connected and running on my machine within no time, literally just a matter of taking the box, stripping back the wires and putting the appropriate connectors on to match my machine. So that was also made easier by the fact that I've had other Endurance lasers already connected to my CNC router, so for me it was pretty straightforward. And as I say, I did lots of measurements, lots of calculations, which are you've already seen in the video. So again, thank you to Endurance for allowing me to test this product out. I'm sure I'll be doing more tests, and if I discover and when I discover anything additional, I will post that information also on this same channel. So again, I hope you find this interesting. I'm sorry that it's a very long video, but I wanted to cover all the possible detail that I could. So thank you, and we'll see you again later.